Okay. So in this lesson, we are going to talk about using experimental probability to make a prediction. Do you know what the meaning of the word prediction? What the meaning of the word prediction? And how we can use experimental probability to make a prediction? You know how? Hmm.
To predict something.
Yes, to predict something, to expect something to happen by using the probability, right? By
Yes.
using the probability. Okay, then by using the probability, you can make a prediction, which means you can use your decision according to this probability. So let me give you an example. Scientists study data to help them make predictions. We can use our probability knowledge to make predictions. Then, for example, you have an experiment and you record the results with a small sample or with a small group. And you want to know if you are going to work with a large group, what you have to do. Then, David found that the experimental probability of him making a blue eye when throwing darts is 2 out of 10 or 20%. If you will choose change 2 out of 10 into percent, then 2 over 10 times 100, it will be equal 20%. Out of 75 throws, about how many blue eyes could he predict he can make? So at the beginning, he made an experiment out of 10, right? He wants to know if it's out 75, how many blue eyes could he predict he can make? You know how he can make it? Then now he made his experiment, right? Out of how many? His experiment, it was out of how many? Mm.
75.
No, out of 10. At the beginning, it was out of 10. Out of 10, he got 2. Then we have two methods. The first way, we can use a proportion. 2 out of 10, it will be how many out of 75. Then we will use cross product to find the answer. Then we can make 75 times 2. It will be
Plus 10.
equal 10x, right? We can make cross multiplication. So the first way to use a proportion, 2 out of 10, it will be how many out of 75. Then cross multiply, it will be 10x equal 150. We will divide both by 10, so the answer it will be equal 50. So this is the first way. As I said, we can use a proportion to find the answer. Another method used a percent equation. We said that it was 20%, right? So we can calculate 20% of 75. So the first method was what? Proportion. The second method was percent. So it will be 20%, which means 20 over 100 or 0.2 times 75. It will give us 50. Then we will use two different methods to find a car rental company sells accident insurance to 24% of its customers. Out of 550 customers, about how many customers are predicted to purchase the insurance? Okay, how we are going to solve this question? We have the percent already, so we will find 24% of 550. It will be 24%, which means 24 over 100. Okay, it will be in decimal form 0.24 times 550. It will be equal 100. The value of x, it will be how many? It will be 132. So about 132 customers are predicted to purchase insurance. This is in case if we have how many customers?
550.
550 customers, right? So this is in case we have 550 customers. Let me ask you a question. In case we have 1,000 customers, how we can calculate? How you can predict in case if you have thousands customers?
0.24 multiply 1000.
So in case we have just customers, right? How many customers are predicted to purchase the insurance? So we will use here, we said that we have 132 out of what? We can use the proportion 132 out of 500, right? So it will be how many out of 1000? Who will give me the answer now? How we will find the answer for X?
132 multiply 1000 divide
Exactly.
500.
Yes, 132 multiply 1000 divided by 500. So the answer will be what?
264.
264?
Yes.
Yes. So the answer, it would be equal 264. And you can answer it by another way, 264. We can say that, what is the relation between 500 and 1000? What happened to 500 to be 1000? We multiplied by how many? Multiplied by how many? Multiplied by 2, right? So we can say directly 132 multiply by 2. So the answer, it will be 264. Then you have two different ways. We have many ways to find the answer for the same question. So this is how we can use experimental probability to predict to predict. Understood this part?
Yes.
Okay, Ibrahim, understood? Okay, in next part, we want to know using experimental probability to make a qualitative prediction. A prediction is something we reasonably expect to happen in the future, right? So we said prediction, it's something we reasonably expect to happen in the future. A qualitative prediction helps us to decide which situation is more likely in general. So you want to differentiate between two different events. So we want to know which situation it will be more likely. How we are going to decide it, it depends on the prediction. Then, a doctor's office recorded data and concludes that on average 11% of patients call reschedule their appointment per week. Then a doctor's office record data and concludes that on average 11% of patients call to reschedule their appointment per week. The office manager predicts that 23 appointments will be rescheduled out of the 240 total appointment during the week next week. Is this reasonable? So we want to know if this number was correct or not. He said 23 appointments will be rescheduled. So how we are going to be sure that this one is reasonable or not? We will calculate at the beginning. He said the total number of patients was 240. Then we want to predict. We can use proportion. 11% means 11 out of 100 equal how many over 240. Then we will use cross product to find, or we can use the percent, 11% of 240. Then 11% of 240, it will be equal, did you calculate it? 0.0, 0.11
26.4.
240, it will be how many?
26.4.
26.4.
Yes.
Yes, 26.4. Then the production said what here? The production said that it was what? 23. Huh. It's reasonable, but it's a little low, because when we calculated already by using the experimental probability, we found that it's 26.4, right? But the
Yes.
manager predict what? He said 23. Is this one reasonable? Yes, it's reasonable, but it's a little low. It's not exactly. Understood? Another example. In emails to monthly readers of newsletter, 3% of the emails come back undelivered. The editor predicts that she sent out 12,372 emails. She will receive 437 notes for undelivered email. Should we agree with her production? And we want to explain. Then we will explain now. We have how many percent? We have 3%, right? We have 3%. Then we will calculate 3% of 12,372 or 0.03 times 12,372. It will give us the answer. The answer, it will be equal 3,371.16. Did this one is reasonable? 371, but they said what? 437. يبقى 371 emails out of 12,372 will come back undelivered. So the production is too high. She expected a number very high. So we can use proportional reasoning to make quantitative production and compare options in real life. An online poll for a movie site show its polling results for a new movie if a newspaper survey 150 people leaving the movie. How many people can it predict will like the movie based on the online poll? Is the movie site's claim accurate? If the newspaper has 104 people say they like the movie. So we want to calculate. We want to use mathematics now. Did you like the movie? How many percent said yes, they like the movie? How many percent they like the movie? 72%, right? So we will calculate now. 72% of 150, they said yes, they like the movie. It's how many? It's 108. Since 108 is close to 104, the newspaper survey and the online poll show about the same percent of people like the movie. So it was production. It was reasonable. Understood this part? So yes, the movie site claim is accurate. The last question. On average, 24% of customers who buy shoes in practical store buy 2 or more pairs. One weekend, 350 customers purchase shoes. How many can be expected to buy 2 or more pairs if 107 customers buy more than 2 pairs? Did more customers than normal buy 2 or more pairs? How you can calculate it? How you can calculate it? Who will tell me? We will calculate what first?
24 over 100.
Exactly. 24 over 100 equal?
X over 350.
Exactly. X over 350. Then we will
It will be
predict the
24
number.
multiplied 350 divide 100.
Very good. So the answer, it will be what?
84.
84, right? But he said here that 107. Do you expect their production? 107 is 2 more, right?
Yes.
Did more customers than normal buy 2 or more pairs? Yes, because 107 more than 84 more customers than expected bought 2 or more pairs. So this is our lesson today, how we are going to predict by using experimental probability. This was lesson 12.2 in our